Welcome to parametric form of a function and relation. So we call them parametric equations because we're going to express two related variables, such as x and y, in terms of a third variable. The third variable is called the parameter. When we looked at trigonometry and we started with the unit circle and we used Pythagoras' theorem with x squared plus y squared equal to 1, we allowed x to equal to cos theta and y equals sine theta because they were opposite over adjacent, opposite over hypotenuse and adjacent over hypotenuse. And the parametric equations were where theta was the parameter. So that's how we formed the parametric equations there. These will come up in this video again anyway. So here we've got parametric equations. You can see each of them has x and y in terms of another parameter. So the first two in terms of t and the final one in terms of theta. And we want to find the original Cartesian x in terms of y. So the first step is to rearrange x equals t plus 1 to make t the subject. So you can see we minus the 1 over and then we divide by the 2. Hopefully you can see where this is going. And we sub that into the y formula. So y outside of 4, y equals 4 outside of the t value, which is x minus 1 over 2, minus the 3. And when you collect like terms, you get y equals 2x minus 1. So that's the parametric, that's the Cartesian equation, because we can plot that on a Cartesian or an xy axis. The second one, we're going to do the exact same. You're going to rearrange to make t the subject, and then substitute the t wherever t is into the y. So obviously the y one is a quadratic, so we just sub x plus 3 in where the t is, and we get y equals x squared plus 8x plus 12. So for the next one, we're going to rearrange both sides to make the trig function the subject. And so we get sine theta is equal to x on 3 and cos theta equals y on 3. And we know that from our trig identities that sine squared theta plus cos squared theta equals 1. So we replace that with what sine theta and cos theta equal, and then multiply by, because 3 squared on the bottom is 9, multiply the 9 across, we get x squared plus y squared equals 9. And you'll notice we get a circle with radius 3. So for the second lot of examples, we're going to do the reverse. We're going to write the following Cartesian equations in parametric form. Now this can be done in multiple ways, and you'll see multiple answers in the text, or potentially multiple answers in the textbook. We're going to just do the simple one, which is for the first two, we're just going to replace x with t and then make y the subject. So if you let x equal t, you get 3t plus ty minus 4 equals 0. And if you just make y the subject, you've got your parametric equations x equals t and y equals 2 minus 3 on 2 t. So they're your two parametric equations. Same with the second one. If you make x equals t and make y the subject, so you get t squared on 9 equals y plus 2 and then minus the 2 over. So your parametric equations are x equals t and y equals t squared on 9 minus 2. One's a little bit harder. So we have to arrange it in the form of a circle. So that we can actually just get it into the form of sine squared theta plus cos squared theta equals 1. So dividing by the 16 allows us to get it to equal to 1. The 16 is 4 squared, so let's make it into a x minus 1 over 4 all squared and y plus 2 over 4 all squared. And that now gets us into the form of sine squared theta plus cos squared theta. So if you let the first bracket be sine theta, then you can get the parametric equation for x. So you multiply by the 4, add the 1. And if you let the second equation equal to cos theta, you get y equals 4 cos theta minus 2, giving you your parametric equations as x equals 4 sine theta plus 1 and y equals 4 cos theta minus 2. Thank you.